All right, let's just dive right into this explainer. Today we're unpacking a genuinely fascinating new paper by researcher John Cantillo titled Microtubules Constraint Organization and Conscious Accessibility. And honestly, this framework promises an absolute paradigm shift. It literally takes everything we kind of just assume about how our brains produce our inner lives and turns it entirely on its head. This is basically the ultimate whodunit of neuroscience, right? For decades, the standard scientific consensus has just assumed that the brain acts as a factory, literally creating consciousness ex nihilo, out of nothing. We call that the generative assumption. But what if that's fundamentally backwards? What if your brain is actually more like a filter, a regulator, or a set of constraints acting upon conscious accessibility? To tackle this without drowning in academic jargon, we're going to follow a pretty straightforward roadmap. We'll hit the consciousness generation problem, explore a really helpful parking lot analogy, break down the contributory constraint framework, look at microtubules as regulators, test the boundary conditions, and wrap up with a brand new scientific direction. Okay, part 1, the consciousness generation problem and the limits of localized production.
So look, there is a massive difference between altering something and actually generating it. We have mountains of evidence showing biological dependence. Obviously, if you undergo general anesthesia or suffer a brain injury, your conscious experience changes. But does dependence equal generation? Think about it like this. If you smash a guitar, the sound changes or stops entirely, right? But the guitar itself didn't generate the underlying mathematical laws of music. In the same way, altering consciousness doesn't automatically prove the brain creates it out of thin air. Cantillo argues that if we ever want to solve the mystery of consciousness, we really need to stop confusing correlation with generation. It's a huge trap. When neuroscience finds a specific brain state correlated with a specific thought, that is incredible science, but it is just correlation. To actually move forward, we need a fourth kind of explanatory relationship: contribution and constraint. This is the idea that biological structures don't generate the experience, but rather they organize it, stabilize it, and make it accessible to us. Which brings us to part 2, the parking lot analogy, where we visualize this idea of constraint. Picture a massive, unpaved field used for parking. It's just total chaos, cars distributing everywhere in a completely inefficient mess. We've all been to a festival parking lot exactly like that. Now, imagine you paint bright white parking lines on the ground. As the paper points out, painting those boundaries doesn't alter the mechanics of the cars, and it doesn't inject any new energy. But suddenly, the global organization of behavior changes completely. Those painted lines didn't build the cars, but they constrain the chaos into a highly stable structure.
This hits the nail on the head for what Cantillo is arguing. Think about a thermostat. It regulates the temperature in your house, but it doesn't actually generate the heat itself, right? Or traffic signals. They regulate movement without producing the locomotion. Just like those systems, your brain might regulate and constrain your conscious access. Your neural architecture provides the painted lines that take a vast field of phenomenological possibility and organize it into the stable, coherent waking experience you are having right this second. So, moving into part 3, the contributory constraint framework and layering the mind. How does this actually map onto human biology? Well, the paper suggests our waking experience is built on interacting layers of these constraints. First, you've got neural constraints. That's your large-scale brain networks and physical biology stabilizing conditions. Then, phenomenological constraints. These dictate the feeling of time passing or the sensation of being localized inside a physical body. And finally, organizational constraints, which ensure your sense of identity actually persists from one second to the next. Consciousness isn't just one magic spark. It's the result of all these overlapping layers filtering reality. Now, to map out the space where all this possibility exists, the paper uses a term called omnon. And let's do a quick reality check here to keep things strictly grounded. Omnon is absolutely not some mystical ghost dimension or a new physical field. It's purely a conceptual tool. Kind of like how a state space in physics describes possible movements without actually creating the movement, omnon is just a descriptive language for how conscious organization can vary. All right, part 4, microtubules, regulators, not generators. If you follow consciousness research, you've probably heard of microtubules, these tiny dynamic protein structures inside your cells. They've been pretty controversial. Older theories, most famously Penrose and Hameroff's work OR model, suggested these microscopic tubes literally generated consciousness using quantum coherence. But this new framework, it proposes a totally different role. Looking at recent research on how anesthetics physically interact with microtubules to shut down consciousness, it suggests we don't need them to be magic quantum generators at all. They just need to be accessibility stabilizers. So instead of generating consciousness, microtubules act a lot like the cellular traffic lights or thermostats we talked about. They modulate transitions. Have you ever wondered why, when you go under general anesthesia, massive portions of your brain are still firing normally, but your consciousness completely vanishes? It's wild. This framework argues it's because the anesthetics are disrupting the microtubule networks that stabilize your constraints. Basically, the painted lines in the parking lot get wiped away, and conscious accessibility is temporarily lost. Next up, Part 5, Testing the Boundary Conditions and Extraordinary States. What actually happens when these biological constraints get loosened or disrupted naturally outside of a hospital setting? Across history, we have tons of reports of extraordinary states, near-death experiences, deep contemplative absorption, things like that. Under the old localized generation model, severely disrupting the brain should just result in garbled noise or darkness. But when we look impartially at these states, we consistently see people reporting time dissolving or their sense of self expanding way beyond the body, and yet their experience remains incredibly coherent and deeply meaningful. And just to be super clear here, the paper explicitly notes we are not saying these experiences objectively prove your soul leaves your body or anything metaphysical like that. Not at all. We're treating these reports as scientific boundary conditions. They're stress tests. They show us exactly what phenomenological experience looks like when the brain's standard, everyday constraints are drastically reorganized. Finally, Part 6, a new scientific direction, predictions and falsifiability. Because, look, a paradigm shift is really only useful if we can test it, right? And this framework gives us some concrete, falsifiable predictions for future research. It predicts we should stop looking for a tiny, static consciousness generator in the brain and instead study transition dynamics, the exact moments of waking up or falling asleep. It also predicts that altering intracellular structures, like those microtubules, will change the continuity of a person's experience without necessarily altering the actual sensory data, like vision or hearing, that they're taking in. There's a great quote from the paper that sums this all up perfectly. Cantilo writes, "The significance of microtubule research may therefore lie less in revealing where consciousness originates and more in revealing that conscious accessibility may depend upon interacting biological contributions operating across multiple scales. We really need to pivot from asking where is it generated to how is it organized and constrained." So, as you go about the rest of your day, really think about this. It's a profound idea. Think about those painted lines in the parking lot. Your brain, with all its billions of intricate networks and tiny microtubules, might not be producing the spark of your experience at all. Instead, it might be actively filtering a vast, overwhelming spectrum of possibility down into the single, highly constrained, brilliantly focused moment you are living right now. And if that's true, what else might be accessible if those constraints were shifted? It's a question that completely redefines the entire frontier of neuroscience.